In this video, we will see the inconsistency of the OLS estimates whenever there is the omitted variable bias. Let's say that the true data generating process is equal to y, that is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus u. Now, there are many reasons for some reason, to exclude x2. Maybe we don't expect it to be relevant. Maybe we didn't measure it. But let's say for whatever is the reason, the model we estimate that will be different from the true data generating process will be y, that is equal to beta 0 plus beta 1 x1 plus v. Now, since the true data generating process includes x2, in the model we are estimating v contains that excluded variable. That omitted variable is here in some way, is in the error. So we have that v is equal to beta 2 x2 plus u. U is the part that is uncorrelated with the explanatory variables. So we know that the probability limit of beta hat, it is equal to the covariance of x and y divided by the variance of x. Now, the fact is that in this y, there is x2. So we have to consider it. So we need to compute the covariance of x and beta 0 plus beta 1 x1 plus beta 2 x2 plus u, all divided by the variance of x. Now, the covariance of x and beta 0 will be 0, because beta 0 is a constant term. The covariance of x and beta 1 x1 will be equal to beta 1 that multiplies the variance of x, and then we divide by the variance, so it will be 1. So we have that is equal just to beta 1 plus the covariance of x and beta 2 x2. So we take out beta 2, and then we have the covariance, I forgot to put the 1 here, the covariance of x1 and x2 here, divided by the variance of x. The covariance of x1 and u will be just 0, because in the OLS assumption we have mean independence of u. So we have that the probability limit of beta at 1, beta 1 hat, it is equal to the true value of b1 plus b2, the covariance of x1, x2 divided by the variance of x. So this is the variance, this is the bias that is due to the omitted variable, because if the omitted variable has a positive correlation or a negative correlation, some kind of correlation with x1, then it will lead to a bias, because to be really clearer, this stuff has to be equal to 0 to have consistent estimates. Whenever this is different from 0, we have a bias. And so it will be inconsistent, because in the limit, in the probability limit, then it will not converge to the actual value. I like to make a little table that summarizes this information. So we analyze the case when the covariance of x1, x2, and x2 is positive, and when the covariance of x1 and x2 is negative. Then we put beta 2 here for the case when it is larger than 0 and when the case it is smaller than 0. So in this case we are considering the relationship between the two variables, the one included and the one excluded, and here its effect on y. So in this case the probability limit of beta 1 hat will be larger than the actual beta 1. In this case will be smaller than the actual value. Then when we have positive covariance and negative sign of beta 2, then the probability limit of beta 1 hat will be smaller than the actual value of beta 1. And when there is negative covariance and negative sign of beta 2, the probability limit of beta 1 will be larger than beta 1. So in the end, this is what we are talking about when we are dealing with some inconsistency due to omitted variables.